Hi everyone, today I'm going to go through LHopital's rule. So what is LHopital's rule? Okay, the main thing about LHopital's rule is to find limits, okay, which gives indeterminate form. Okay, what is indeterminate form? Okay, indeterminate form is 0 over 0 or infinity over infinity. Okay, so when you have limits which reduces to 0 over 0 or infinity over infinity, you can use LHopital's rule. Okay, so another thing I would like to mention is, other than infinity over infinity, also can be minus infinity over infinity. Okay, or infinity over minus infinity. So all these indeterminate form can be used, can be solved by using LHopital's rule. So let's now we state what is LHopital's rule. So LHopital's rule states that if limit x approaches to a value, let's say x approaches to a, fx over gx equals to 0 over 0. Okay, so this is one of the indeterminate form, or limit x approaches to a, fx over gx is equals to infinity over infinity. Of course, the variation can be minus infinity over infinity or infinity over minus infinity. Okay, so you have this indeterminate form for the limit, or this as the indeterminate form of the limit, then you have to use LHopital's rule. Why? Because it makes this is indeterminate form means undefined. Similarly, all these are undefined. That means we still could not decide what is the value of the limit. That means it could be a value, or it could be infinity. So the limit of the actual limit is still unknown. Okay, so if this is the case, then limit x approaches to a, fx over gx is equals to limit x approaches to a, f prime x over g prime x. So what is the difference? There's a differentiation, right? So there's a derivatives of the numerator over the denominator. Okay, so you evaluate. So evaluate, that means evaluate the limit. the limit. If after evaluation is again indeterminate form, then we have to continue the differentiation process. So if this is true, then we have to equals to limit f double prime over g double prime. Okay, same thing. We'll continue to do the differentiation if it's still the answer is still indeterminate. Okay, so when do we stop? So we continue until the limit approaches to a value. That means the limit could be L or infinity. So you stop when it reaches L or infinity. When you evaluate the limit of the last derivatives of the numerator over the denominator, and the result is L or infinity, then we stop our differentiation process. So this, let's say, is still indeterminate form. Then we continue. Okay. So I will illustrate an example to show actually how it really works. So we have example 1 in your slide. So actually it's pretty simple. Okay, so first we write down the question. Limit x approaches to 0 ex minus 1 over 2x. Now first you evaluate, so you get e0 minus 1 over 2 times 0. You get 1 minus 1 over 0, so you get 0 over 0. So confirm this is a indeterminate form limit. Okay, so indeterminate form limit, we have to differentiate. So you can prime, put a prime is you're going to differentiate. It's prime. Then you have dx over 2. So you check again. E0 over 2, which is half. So that is the limit. So that actually is the actual limit. So the answer is, the actual limit is half. It's not. You can see from the example, the actual limit is E0 over 2, which is half. Right? It's not 0 over 0. 0 over 0 is not the actual limit, but half is the actual limit. Okay, so I hope you understand that it helps. LHopital Rule help you to evaluate a limit which give you an indeterminate form. Okay, now we go to example 2. Limit x approaches to infinity, ln x over x. So again we check. So ln infinity over infinity, which is infinity over infinity. So this is an indeterminate form. So we differentiate. Ln x prime over x prime. Prime, not 1. So limit x approaches to infinity. Ln x differentiate, you get 1 over x. X you differentiate, you get 1. So you get x approaches to infinity of 1 over x. Of course, this is 0. Right. So again, we can see initially we thought infinity over infinity is the final limit, but because it is the indeterminate form, So we apply LHopital's rule, and finally we get a actual limit. 0 is the actual limit for this question. Okay, now we can go through example 3. So same thing, write down the question. Limit x approaches to 1 plus sine pi x over square root x minus 1. So we can check first. Is it indeterminate form? Sine pi over square root 1 minus 1. Sine pi is 0. So it's indeterminate form. So you have to differentiate. Applies the LHopital rule. Okay, so you can use a square bracket to denote your differentiation, the square bracket. Okay, so after that you differentiate. Sine will become cosine times pi. Over, so bring down the power, and the power minus 1. So you simplify, so you get 2 pi limit x approaches to 1 plus cosine pi x over x minus 1 minus half. So of course you can split the limit. So you can see when you put 1, you get 0, right? You put 1, you get minus 1. So of course the answer will be 2 pi minus 1 times 0. So you get 0. So as you can see, the indeterminate form is 0 over 0, which is not a limit, and 0. Finally, you use LHopital's rule, you can get the actual limit, which is 0. Okay, now we can start example 4. So limit x approaches to infinity, x cubed over e2x. So again we check the value of the limit before we decide whether to use LHopital's rule or not. Okay, so we get infinity over infinity. So no choice, we have to differentiate. Using LHopital's rule, we have to do it. Find the limit using LHopital's rule. We get 3x squared over 2e2x. Now again is infinity over infinity, right? So again we differentiate the numerator and the denominator. So again this is infinity over infinity. So we do it until we finally have a limit or infinity. 6 over 8e2x. So this one, you can see this will become infinity, right? So anything over infinity is a number over infinity will give you 0. So we write as like that, 6 over 8 limit x approaches to infinity e2x. So we get 0. Now the next example 5. Okay, we x approaches to 0, x cubed over x minus tangent x. So first you put 0, 0 over 0 minus tangent 0. So you get 0 over 0, okay, which is your indeterminate form, right? So no choice, you have to use LHopital Rule. That means you need to differentiate. So you write equals to limit x approaches to 0, 3x squared, correct, over, now tangent differentiate, you get secant squared. Okay, so again you put x equals to 0 into the numerator and the denominator, you get 0 over 1 minus secant square 0. Now what is secant square? Secant square is actually minus 1 over cosine square 0. Of course, which is 0 over 1 minus cosine 0 bracket square. So you get 0 over 1 minus, now cosine 0 is 1, so 1, so you get 0 over 0 again, right? So again you have to use LHopital Rule. So now we do the differentiation carefully. So 3x squared, so you get 6x. Now 1 minus secant square x, differentiate. Okay, now how to differentiate 1 minus secant square? So this is the part that you have to be careful. So 1 minus secant square x prime, so we get 0 minus secant square x prime. Now secant square x means secant x bracket square. So when you differentiate, you get minus 2 secant x times secant x prime. Now secant x prime, when you differentiate secant, you get secant x tangent x. Okay, so here you should write minus 2 you can take out, secant x times secant x tangent x. So now what happened to, now further simplifying, we get secant square x. And then using the identities, so this one will give you 1 plus tangent square x. Okay, so secant square x will give you 1 plus tangent square x. So that is the formula for identities, times tangent x. So you open the bracket, you get tangent x plus tangent cube x. Okay, so this whole chunk here, so you can see that this whole chunk, the whole chunk here is to differentiate your 1 minus secant square x. Okay. Okay, this whole chunk, let's draw a box, this whole chunk. Okay. me finish up this thing first. Tangent cube x. Okay, so this whole thing here is to do your differentiation of tangent of 1 minus secant square x. So the prime I put the right inside. Okay, so this is your prime. So now after that, so you say therefore equals to limit x approaches to 0, 6x over minus 2 bracket tangent x plus tangent cube x. Close bracket. Now 6 and 2 can cancel, so you get 3. Right. So eventually you get to limit x approaches to 0. Now the negative sign will go on top, so minus 3 over tangent x plus tangent cube x. Now again you test, right? So you sub 0 into the numerator, get 0 over tangent 0 plus tangent cube 0. So again is 0 over 0. So again is indeterminate form. So indeterminate form, again we differentiate. So limit x approaches to 0. So minus 3, right? So this one tangent x plus tangent cube x. So differentiate. So again you can do a kind of differentiation and show the step involved. So tangent differentiate, get secant square plus tangent cube x prime. So equals to secant square. Means tangent x cube. Okay, you differentiate. So get 3 tangent x bracket square times secant square x. Okay, so we can actually take out the common factor, and 1 plus 3 tangent square x. So now we can continue. So it will be equals to limit x approaches to 0 minus 3 over secant square x, 1 plus 3 tangent square x. So when you put 0, this is 1. When you put x as 0, this is 0. So finally you get minus 3 over 1 times 1 plus 0. Okay, so you get minus 3. So this is the final answer. So minus 3 is the limit for this question. Okay. So the next video I will continue with LHopital Rule again, which is the second part that help us that we will apply to evaluate indeterminate form of another types now. Okay, so I will see you in the next video. Thank you very much for your attention.